Module 4, Lesson 2, we are going to be talking about interpreting fractions as division. We're going to look at our division equations through this context. We have blank crackers and blank people. How much will each person get if they share the crackers equally? We talked about our context being that we have crackers and people and that they are sharing those crackers. When you look at our quantities, we have our blank quantity here for crackers and our blank quantity for people. But we know in our question, we want to know how much each person is getting, and we want to know that they're sharing those crackers equally. It's really important to know that we're sharing equally, because if it's not equal, all the people could get a different amount of cracker. So here's our first situation. We have one cracker and two people. How much will each person get if they share the crackers equally? So we have this one cracker, and we are dividing it by 2 because we're giving it to 2 people. And so to make this happen, we can't just give one cracker to each because we don't have enough. So what people usually say is like, oh, we just split it into half. And one person gets 1/2 and the other person gets the other half. So our answer would be 1/2. And at this point, we made the conjecture in our classroom when we noticed that we have 1 divided by 2 equals 1/2. And we started to think, I wonder if that would apply to other situations. The conjecture that we came up with is the starting amount becomes the numerator and the divisor becomes the denominator. So if you look over here, we have our starting amount 1, cracker, is the numerator, and the divisor 2 becomes the denominator. So let's see if this still applies with another problem. So with this problem, we have 4 crackers and 2 people. How much will each person get if they share the crackers equally? Now, a lot of people will go, yeah, that's 2 crackers per person, and they would be right. But I want us to try to solve this problem to prove that our conjecture is right. So what we would want to do is, first, we have 2 people. So just like we did with each cracker up top, is we would split our crackers in half so that each person would get a part of each cracker. And we started with 4 crackers, and we divided each cracker by 2 people. And then if we take a look, this top half of our line would go to 1 person, and then the bottom half of our crackers would go to the other person. So when we're answering our fraction, we would ask ourselves, how much did each person get, or how many parts did each person get, and then how many parts in a whole. So each person got 1, 2, 3, 4 parts. And each part, or each whole, has 2 parts. So they would each get 4/2, or 4 halves. So let's take a look and see if this proves our conjecture. Our starting amount 4 becomes our numerator, and our divisor, or how many we're dividing into, becomes our denominator, 4/2. Another way that people were looking at this is saying, hey, I could rename 4 into halves, and I would have 2 halves, 4 halves, 6 halves, 8 halves. And I'm still dividing those 8 halves into 2, which would leave me with 8 divided by 2, which would be 4, and then I can't forget my unit, which would be halves. So we would have 4/2, which could also be written in standard form as a fraction as 4/2. So let's take a look at our homework and apply our conjecture to our homework. 1C is 7 divided by 4, and it asks us to draw a picture. So I'm going to use the same context that we were using, crackers and people. So I would have 7 crackers and 4 people. So I know in order to prove my conjecture that I'm going to need to divide my crackers into fourths because I have 4 people. So each of my crackers is going to be divided into 4 parts. So I'm going to do that to each of my other crackers. So I've split all my crackers into 4, and out of each cracker, this whole row will go to one person, the next row will go to the other person, and so on. And now to get our answer for 7 divided by 4, we have to ask ourselves how many parts of a cracker did each person get, or how many fourths of a cracker, because my cracker is cut into fourths. So I'm going to go ahead and stick my denominator in there because I know my whole has 4 parts, and each person got 1, 2, 3, 4, 5, 6, 7 parts. So 7 fourths would be the answer, which also proves my conjecture. You can also write this as a mixed number if you wanted. There would be 1 whole with 3 fourths left over. Let's take a look at one more problem, 3b. Here they're asking you to kind of think backwards. They give you the answer and they want to know the equation that goes with the answer. And don't be fooled just because the equal sign is on the left-hand side as opposed to the right-hand side. This first number in an equation is always the starting amount. So when you think about writing the equation correctly, it's not read backwards. The equation is always starting amount first and then your divisor second. Okay, so with this, using our conjecture, the starting amount becomes the numerator. So I'm looking at my numerator here is going to be my starting amount, and my denominator, according to my conjecture, becomes the divisor. So 9 divided by 5 would be the equation for 9/5.